Hi, my name is Debrief, and I'm a civil engineering major at the University of Texas at Austin. I grew up in Sugar Land, Texas, and I became interested in engineering when, in my junior year in high school, my environmental science teacher really started talking to me more about what I should be doing with my future, and she really stressed like engineering could be a good pathway for me because I was good in math and science, and then she was right. More specifically, I chose my major because at the time, I wanted to be a city planner, and so she said that civil engineering would probably be the best way into it. But right now, I don't want to be a city planner as much anymore. I want to go into project management, so like that's like construction, like the person in charge of like construction and things like that. But today, I'm going to show y'all how to make like a tower or any building that you want to using toothpicks and candy corn. So first thing we're gonna need is our materials. In my hand, I have about 100 or so toothpicks. I'm gonna lay them out like right here, okay? And then in this cup, I just have a cup full of candy corn. So before we start building, what you should do is you should just like maybe like jot down and explain like what are some ideas you want to do in terms of constructing, like what shapes do you want to use, how tall do you want it to be, like things of that nature. And maybe even draw out like the tower or your construction thing if you want to, and see like, oh, how am I going to do this? And really like think, explain your ideas and explain your design. And then once you've already done that, we can start building. I'm going to pour some of these out. Okay, that's good enough. And then just going to start. One thing, try not to break your candy corn when you are putting it in, because mine are still breaking. Okay. And really the goal is to try and make the tower as tall as it can go before it starts falling. And I really suck at it, but we're gonna keep on trying until I can make it like a little box. guess I'm just too strong because I keep breaking my candy corn, but we're getting there. Okay, so for the sake, let's imagine that I was a better builder and I actually built a really big tower, right? But like right now, obviously it's not happening, but let's just imagine. So you're looking at my wonderful tower and you're saying, oh my God, like how did he build it to get that tall? Well, now let's like debrief and see like what worked best, and we can say how maybe you would have failed it, how I failed, and talk about how we can be better. So like again, talk about what worked best, write that down, jot that down. Also, you can write down, maybe even draw like how you can improve, how so next time if you do this again, you can say, oh, I did poorly like this, let me try and do better by doing this, right? And even though this was just a fun little activity, there is a connection to real world engineering. In this situation, you had to draw, and you could have drawn and designed the building on top of having to build it, but that's not really the job of an engineer. You were actually playing the role of the architect and the engineer. In most situations, the architect is the one who will design the building, and the engineer is the one who will then either build it or see if the building is even possible to be built and if it's safe to be built. So when you drew your building, you could have drawn like you want to make a big tower, and then when you start to build it, you realize that, oh, that's not possible, and so you start to make changes. The second role would be you as the engineer, but again, you just drawing and thinking about, oh, how I'm going to design this building. It's just you as the architect. And now more so on, I want to say, building the actual tower. What I was doing, I actually failed on purpose, because I wanted to show y'all that a lot of times you think that using a square is like the best way to build something, because you see squares everywhere. You think that, oh, this building's a square, it's probably made out of squares. But actually in most engineering concepts, the strongest shape is actually the triangle. The triangle is stronger because if you were watching when I was trying to build it, you could see that like forces were pulling on every which way of the triangle, or not the triangle, the rectangle, because of just how open and exposed each side of the square is, and this makes it not very structurally sound in terms of like reinforcing. So usually what engineers will build is a triangle, and again, the triangle is used more so in engineering buildings because it's just the more sturdy shape fundamentally due to it only having 3 sides, and there's no real like side openly exposed to bending because the triangle has more points and corners, being that the top will be here, bottom along this side, and then imagine another joint and just keep on going and so forth. And because of that, the triangle is stronger to bending because you can't really bend the point as much as you could bend like the top of a rectangle. And that's why triangles are more used in terms of building and things of that nature. Arches are also used, like an arch, maybe you'll see like an arch is like part of a circle, not a half circle, but like similar to that. And arches are used like that because again, when you put that like a force or any type of like action downward onto the arch, it mainly disperses and the force is shared throughout the entire thing rather than just being on one force with a toothpick and then break it. So that's why we use arches and triangles in terms of building and things like that. well, that's really it. I'm sorry I wasn't able to like fully build the actual tower because engineering's hard, and I wasn't able to do it. I know that y'all will be able to do it though, because I have more faith in y'all than I have in myself sometimes. So I want to say thank you for completing this activity with me, and I hope you found it helpful, and I hope it really like shows you how engineering can be fun while also hard. I hope y'all have a great time, and welcome.